Okay, starting.
On
Yes.
direct. So
Yeah.
please. Yeah, so
Hi. Oh, yes.
yeah, good afternoon, everybody. I hope many of you are connected today for this Hangout session and for listening to the different answers that we have to provide to your questions that were asked during the week on the website of the MOOC. So thanks to GB for organizing this session. So this is the next week is the last week of the MOOC. So you have to be ready to pass through the exam at the end of next week. And I hope that today we will help you by answering some of your questions. So
Okay.
please, GB, give us the questions.
Okay. Um, Hi, everyone. And the first question is from Steve from Montreal. And he mentioned something from the class that from Dr. Marchand, that a major component of immunity in early life is transferred from maternal antibody to fetus. However, maternal antibody is also decreased the response to the vaccine. I mean, can you help explain why is that happening?
Yes. So there are two important things to understand about that. First, of course, the mother transmits to their baby their immunity to a certain number of diseases. When these antibodies are able to be transferred from the mother to the baby, and this is the case for some viral infections. And this is, of course, a way that the nature has found to get the baby protected during the first weeks of birth, when the baby is very fragile and has a problem with the development of the immune system at this age. So, for example, in the case of measles, we know that the mothers who have been infected by measles, they transmit for a number of months, between 3 to 6 months. They are able to transmit to their babies a certain level of antibodies that allow the babies to be protected from measles. But these antibodies at the end tend to disappear after 6 months, so the baby has to be vaccinated. So in that case, if you immunize the babies too early, the vaccine will be hampered. The take of the vaccine will be more difficult because of the antibodies from the mother who are circulating into the blood of the baby. But after 6 months, this doesn't anymore happen. Another observation, very important in the case of measles, is that now the young mothers, they didn't have measles. They were not infected, they were vaccinated. And in that case, the level of antibodies that they have is much lower. So they transmit to their baby a much lower level of antibodies, maybe 1/10 level of antibodies. And in that case, now we know that because a number of studies have shown that these antibodies disappear more rapidly. So the babies need to be vaccinated earlier now regarding measles, and due to the fact that the antibodies from the mother. However, this doesn't. This is not an explanation for the problem that the immune system of the baby is very immature. And as such, if you immunize a very young baby, younger than 6 months of age, with a paramyxovirus, for example, like mumps or like measles or vaccine,
Okay.
difficult to immunize because of an immaturity of immune system. So there is no, as it is said in the question, there is no contradiction in this observation. Yes, the maternal antibody may block immunization of the baby in some instances, and in other instances, this is useful to protect the babies before immunization for a short number of a period of time. short, maybe 6 months, maximum 6 months.
Okay, so that's why we have to we have a schedule for immunization for the baby and for the mother, right?
Sure, which is of course the schedule for the baby vaccination immunization is based on the immaturity of the immune system,
Okay.
and the MMR vaccine is given after 1 year of age. But in some instance, we would need to give this vaccine earlier, maybe at the age of 9 months or 8, or even earlier, 6 months of age. In some countries in Africa where measles is still circulating a lot.
Okay.
But in that case, the presence of the mother antibodies, which is no more the case now because the mother has been vaccinated. So the level of antibody that circulate is lower, much lower.
Okay.
So this needs to be figured out every decade before changing the schedule of a vaccine.
Okay. Okay. Thank you, Fred. And next question is for Atma. We have been hearing about universal flu shot, and what are the differences between our yearly flu shots and the universal one? Does it mean that if we have the universal flu shot, do we only get it once and that's it? We don't need to get any more vaccine? Or how would it work, and how can we implement this in the field? That's a lot of question. I'm sorry.
Okay. Well, thank you for the question. It's a very interesting and very topical question. So the current influenza vaccine, the seasonal influenza vaccine, has to be given yearly, mainly because the influenza virus changes antigenically, such that the immune response that is generated with the seasonal flu vaccine is not cross-reactive enough with so-called drifted influenza strains. And a universal influenza vaccine, or what some people call a universal influenza vaccines, there are other terms such as a broadly reactive influenza vaccine, would protect against more influenza strains, against influenza strains of different antigenicity that have evolved and have tried to escape the immunity in the population that is given by seasonal vaccination. An ideal universal flu vaccine would protect against all influenza viruses, including future emerging pandemic viruses. But there are gradations of universality. You may have a broadly reactive vaccine that protects for a certain period of time or for a certain amount of antigenic change, or you may have a truly universal flu vaccine. Unfortunately, these vaccines are not available yet, but there's a lot of activity going on at the moment in research and development, and these so-called universal flu vaccines are at various stages of development. So there are some approaches that are still very early stage, that are basically academic research, but there are also some that are already in clinical trials. The approaches that people have taken for universal flu vaccines vary, but essentially they concentrate on conserved epitopes and conserved determinants of the influenza virus. The internal genes of the influenza viruses are more conserved than the surface glycoproteins, for instance, but for that you would need to induce cross-reactive cell-mediated immunity. So some vaccine approaches aim at inducing cross-reactive cell-mediated T-cell immunity. There are also conserved proteins in the envelope. There's the M2 protein, and particularly a short bit of the M2 protein, which is the extracellular bit of the M2, which is called M2E. So that is very conserved and is on the surface of the virus, but it's present in very low amounts in the virus particle. And people have tried to target this. And another quite exciting area of research is focusing on conserved parts of the HA molecule. So the hemagglutinin molecule, the major antigenic determinant of influenza viruses, and the receptor binding protein of influenza viruses. While it is changing yearly and constantly evolving, there are some regions that are quite conserved, in particular the so-called stem or stalk region of the HA. The HA has a structure of a stem and a globular head on top. And it has been shown that monoclonal antibodies can be found and generated, found in humans. I mean, you can isolate B cells and generate monoclonal antibodies from humans that react with these, with the stem of HA, and that these are cross-reactive to varying degrees. So the aim now is to generate vaccines that induce these antibodies preferentially. Current vaccines apparently don't do this. They direct the immunity mainly towards the globular head, which is more variable, and therefore you need to update the vaccine. So I think in the coming years we will see a lot more development and hopefully some promising results, but we'll have to watch this area.
Okay. And this is my own question. Since now that I'm sick, I had a flu shot earlier last year. It's when you get a flu shot, then you can still get sick from a flu, or I'm not sure if I have a flu, but it's
well, yes, I mean,
very bad cold.
There are a number of questions. You may not have the flu now. You may have a different respiratory pathogen, and then obviously the flu vaccine can't help you. But I mean, no vaccine is 100% effective, and the flu vaccine often has rather lower effectiveness in the range of maybe 50%, 60%, 40%. And the flu vaccine is also liable to sometimes being less effective because of a strain mismatch. This should not be the case this year. This year, the vaccine is actually pretty well matched, as far as we know, but still it is not 100% effective.
Okay, thank you. The next question is for Fred. They asked that I would like to ask about the effect of the shortage of injectable polio vaccine after the switch to the bivalent polio vaccine and its effect on the polio eradication plan, the risk of re-emerging of polio 2 virus, and how this situation will be managed.
Yeah, so this is true that the polio virus type 2 has been withdrawn from the mixture of the live oral polio vaccine, the one which is taken on a sugar, the oral live attenuated vaccine. Polio 2 has been withdrawn, and this is in the context of the polio elimination campaign of WHO. This has been done on purpose, but of course, in the countries where this is done, we don't want any risk of re-emergence of polio serotype 2 virus, of course. So this vaccine should be replaced by an injectable polio vaccine. And I'm not aware of shortage of this injectable polio vaccine this day. Maybe I should be, but I'm not aware of that. But this was a big deal for WHO to replace. And I know that a lot of companies, vaccine manufacturer companies, have been running to that goal, producing injectable polio 2 vaccines to replace on the field the live vaccine. So I don't know what is, because I'm not a specialist of this vaccine. Unfortunately, this would have been a question for Francis Del Peru or someone other. I'm not sure. Maybe Otmar, you know about that. But a number of companies are normally working hard to be able to manufacture the amount of polio vaccine which is needed for the elimination program. Are you aware of a shortage in injectable?
I have actually heard about the shortage of inactivated polio vaccine, but I don't know the reasons and the details.
Yeah, the reason is why. The reason is because in more countries the oral live vaccine is withdrawn, because when the number of infection by a live polio wild type pathogenic virus is under a certain threshold, they replace the live vaccine by the injectable inactivated vaccine. Because of this new reassortment that have been observed, where the live vaccine is able to reassort with the Coxsackie enterovirus and give rise to vaccine dependent poliomyelitis. So this is a goal to replace, depending on the results of the elimination campaign, to replace the oral live vaccine by injectable. So for this reason, maybe there is shortage in manufacturing of the injectable vaccine, which is much more difficult to manufacture than the live one. So maybe we can ask details on this question to Francis Del Peru and have a written answer
Okay.
to the MOOC for that specific question.
Okay.
Okay.
Okay. Thank you. And the last question I have, it's actually for Marie Elena Botassi, but she has some last minute travel plan. I don't know if you want to try to answer this, or maybe we can keep it for...
we can keep it also because it's, again, it's a very specific topic.
Okay.
What is an example of a parasitic or neglected disease vaccine that is successful in testing? Parasitic, okay, we have the RTSS malaria vaccine.
Okay.
This is for sure. But neglected disease, I think they are thinking, the question is thinking to other parasites. And this, I don't really know. So we have to ask Maria Elena Bottazzi.
Okay. And maybe on the last, for the flu again, if there is the if it's an effective universal flu shot, so we only get it vaccinated once and that's it. It should cover all the flu for the rest of our life, which I know it would be ideal. But what's your thought on that universal flu shot? One more.
Well, that would be the ideal, but I think that's probably an unlikely expectation. There are a number of factors that play into this. If you have a vaccine that is truly universal in its reactivity, so that it really would cover all flu vaccines, then it just depends on how long-lasting the immunity is that is induced by this vaccine. So it is then possible, for instance, maybe you need to vaccinate once every 10 years or once every 5 years or something like that, depending on the longevity of the immune response. But it is also possible that a future vaccine is not truly universal, that it covers influenza viruses as they evolve for a certain period of time. And after that, you need to update it. And so you might need another shot of a vaccine that is updated to cover you for a following period. And we don't yet know which of these vaccine concepts will be successful, and therefore it's really impossible at this point to predict how many immunizations or shots people would need in the future for a universal flu vaccine.
Okay. So we still have great hope for the universal flu shot, right?
Yes, there's hope, but there's also a lot of work still to do.
Yeah. Okay. Great. Thank you so much for participating in our MOOC Hangout session today. I think we probably gonna keep the rest of the question and ask to the expert, and then I'll put it on the discussion board on the MOOC website. So thank you everyone today, and then hope to see you soon.
Thank you.
Okay. Thank you.
Thank you very much, Otmar.
Thank you. You're welcome.
See you soon in March in Paris.
Yes. See you then.
Okay.
Yes, and GB, take care, please. Hope to see you tomorrow. I know it's Saturday.
Okay.
On Monday. Then.
Okay.